Okay, we should be live. Live with audio. Excellent. Maybe I was turning up the rice cooker. No, I did that last night. Um, yeah, I'm here. I made it. So I was late because I was rabbit holing in preparation for the show. I was one of the questions that I was looking at, the answer was like really fascinating, and I was just like finding more and more information on it, and then like, oh god, I'm late. I thought I had like 5 minutes left, but so yeah, right. So hey everyone, hope you're all doing okay. So if you're wondering what it is that you have stumbled into, this is going to be a live episode of the Question Show. Your questions, my answers. So go ahead and put in the questions that you have in the chat, and then we will gather a bunch of them up, pull them into a database. I'll be able to go through the questions as efficiently as possible. So um, so the right. So just a few things to keep in mind. First, one is like, don't put your question in multiple times, please. Just put it in once. I see it. So if I'm if I'm not answering your question, there's a bunch of reasons. The first one is that I put emphasis for the people who have never had a question answered before. I want you to have your question answered. So I can see how many times I've answered people's questions in the past, and I'm going to try and put as much emphasis on the newbies. But I might not know the answer, right? Like, I'm a journalist. I try to synthesize as much of the space news as I can, but if I don't feel like I know the answer, I'm going to avoid the question. And if the question requires a lot of calculation, like maybe I could work it out, and maybe if I took some time, but do you really want to watch that live? So just keep that in mind, that I might not be going after a lot of questions. Oh, and the screen went on. So just keep that in mind. All right, let's get into the show. I'll start the recordings, and then we will. Okay, we are recording. Welcome to the Question Show. Your questions, my answers. Now, as always, wherever you are across my channel, if a question pops in your brain, I will just... all right, this is again. It's time for the Question Show. Your questions, my answers. Now, as always, wherever you are across my channel, if a question pops in your brain, just write it down in the chat, in one of the comments, and I will gather a bunch of them up and I will answer them here. People ask me, like, what's the best place to do it? And they post that as a comment in the YouTube comments, and then I reply to them that was the place and this was their chance. So yeah, just anywhere, on any video, like I see them all in numerical order. So just go ahead and post a comment in any old video that you like, and I will see it. We do the show live every Monday at 5 p.m. Pacific time. So if you want to have the longer version of the show, it's about double the length, sometimes a little bit longer. And we do live questions. I do overtime, stick around longer. So you might have a lot more fun with that if you want to have the live experience. We do that every Monday at 5 p.m. Pacific time. All right, let's get into the questions. So as I said, I've got some prepared questions. So let's do it. Yes, I am recording. Yes. Okay. Hey Fraser, a thought occurs. If two black holes by an unimaginable fluke had precisely opposite spins and then they merged, would they cancel out? What would a black hole that doesn't spin be like and look like? Yeah, in theory, right? Like all black holes are spinning. And the spin is the angular momentum that's left over from when they were a star and all of the material that falls into the black hole. And it spins it up. And in many cases, it's spinning it up to a significant percentage of the speed of light. And that is just caused by the accumulated material that falls into the black hole. It adds to the spin. And so, yeah, if you had two black holes that merged with each other and they had precisely opposite spins, they would cancel out, and you would be left with a black hole that isn't spinning. And this is like, from what I understand, when you take your advanced astrophysics degree, you learn about black holes. First, they start things a little easily, and they say, like, let's just imagine that the black hole isn't spinning. And then you learn all these calculations based on a non-rotating black hole. And then they go, but really, they're all rotating, and life gets a lot more complicated. And the reason life gets a lot more complicated is because the black hole itself, well, all mass, but especially black holes, as they are rotating, they are frame dragging. They are pulling space and time around with them as they go. And what happens is that when you've got this accretion disk that forms around a black hole, if a black hole wasn't spinning, then actually matter would be able to fall into the black hole, into the event horizon more quickly, sooner than one that is rotating. And one that's rotating, of course, this matter is sort of pulled around, swirled around as it's frame dragging. It gets a lot closer to the black hole. And astronomers can actually calculate how fast the black hole is rotating and how much of a gap there is between the black hole event horizon and the beginning of the accretion disk. And they look for a very specific kind of X-ray radiation that's coming from this accretion disk. There's a very specific kind of wavelength of X-ray radiation that iron gives off as it's just about to die. And in a black hole that is actually rapidly rotating, the energy level is lower because it's actually gotten closer. So I guess it's kind of like stretched out, spread out the amount of time it's taking for that iron to go into the black hole. And with a fast rotating black hole, one of the things that you get is essentially the event horizon flattens out like a oblate spheroid. And the poles of the event horizon sort of come together the faster this thing is spinning. But you can't actually reveal what's inside the black hole. There's like a limit. And so that's the idea of a naked singularity. So you can't get a naked singularity. But I can think of another situation where you might end up with a black hole that isn't rotating, and that is a pet black hole. That is, if you've got some super advanced civilization has a, giant Dyson sphere around a black hole, and they are dropping matter into the black hole to extract the energy. It's called the Penrose process, and it's essentially one of the most efficient ways that you can gather energy in the universe. The black hole becomes a giant battery, and you are dropping material into the black hole. As this material gets broken up, part of it goes in, but part of it gets ejected sort of as it's just about to arrive in the black hole. It actually gets ejected out into space. You capture the energy from that ejected material, and you are harnessing energy from the black hole. But every time you drop material into the black hole and you harvest some of this rotational energy, you are slowing down the black hole just a tiny little bit. And so over vast periods of time, as your civilization consumes an enormous amount of energy coming from the black hole, it will slow down and slow down and slow down. And eventually the black hole will stop spinning, and you will no longer be able to extract any energy from it until you find ways to spin it back up again. You're going to have to go and find some galaxy to tear apart and feed into your supermassive black hole to spin it back up again so that you can then extract that rotational energy again. So that's what a black hole, if it didn't spin, would look like. Got the codes. Okay. Now, I'm sure you've noticed the codes that appeared over my shoulder as I was answering that first question. And these are the ways for you to vote, to let us know which of the questions you thought was the best one. And I'll admit, I was super surprised this week. So the winner was Nabu. Cliff Cottrell asked what would happen if time stopped. I think it was Cliff's daughter asking this fiendish question, and I gave my best shot at answering it. And I was impressed. That's the one that everybody liked the best. So congratulations to Cliff and your daughter. That was a great question. And so once again, go ahead and just type in the name of the Star Wars planet that you like the question best, and we'll gather up all of the votes, and we'll let you know which one won next week. Derivius 2012. Hey, Fraser, when do you think we'll see the first person born in outer space or Mars, assuming it's possible? Surely that would be a pivotal moment in human history. I have no idea when we're going to see the first human being born in outer space or on some other world. And to be honest, we have no idea if it's safe. In fact, we have ideas that it's not safe. Definitely not in microgravity. We don't know if it's feasible for a fetus to gestate on the moon or whether it's possible for them to be on Mars. On the moon, it's 1/6 gravity. On Mars, it's 1/3 Earth gravity. And of course, in space itself, there's effectively no gravity. And we don't know, but there have been some research papers that have looked into what would the potential impact be. How does gravity play a role in the gestation of a human fetus? And there was a paper that I looked at back from 2005, and they talked about the various health implications that would happen to a fetus in microgravity. And so one of the things that you don't realize is that a fetus inside the womb for the first part of the gestation is essentially floating in fluid and really doesn't experience a lot of gravity. Although they do experience some gravity on their internal organs. Once they reach a certain point, it's like after about the 26th week or so, the fetus is large enough that they're starting to sort of be pulled inside. They're feeling the gravity as mom walks around. And they're actually starting to build up their muscle strength and muscle volume. They're actually starting to build up their muscle strength, their heart strength, and a lot of other parts of the body are reliant on this. And so if a child was gestated in microgravity, they would have weaknesses in their spine. They would have a lack of muscle tone in their legs. They would probably have a harder time with their heartbeat. And so there would be a ton of health implications, especially if this child then tried to come back down to normal gravity. And it just it doesn't sound like it's ethical to put a human being through this, right? Mommy and daddy wanted to live in space, and so you have to use a wheelchair now if you want to live on Earth. It doesn't seem fair. So there is a long line of experiments that are going to have to be done before we can get to a point where we know what is the actual amount of gravity. There have been some tests done with rats. They're not a great stand-in for human beings. The researcher that I mentioned, they suggested using guinea pigs, which are a better model than human beings. But really, we need to have some kind of experiment where guinea pigs or even larger creatures go through the entire gestation process in various levels of gravity. This again, we have to do some kind of experiment where various animals are gestated in different levels of gravity, from microgravity, essentially zero gravity, through lunar gravity, through Mars gravity, and in some kind of artificial gravity system, like a big centrifuge where these animals are born, they live their lives at different levels of gravity to find out. And then from there, you have to very carefully, excruciatingly move forward. I mean, again, human lives are on the line here, the health of human beings, and to just move forward without having done adequate amount of research is really unethical. So I think that and that when human beings are together, they're not going to think about the consequences of their actions. And so people are going to attempt to procreate in space. They're going to attempt to procreate on Mars before adequate research has been done. And that is, again, not a smart move. So I wouldn't be surprised if there were a lot of very severe planning done. Talk about Planned Parenthood to the nth degree here with in space. So no idea when this is going to happen. It's inevitable. I'm sure at some point someone will be born in space, on Mars, on the moon, but it's going to be a long time before we know that this is a safe thing to do. Dirty diaper, zero gravity. Oh, I with two children, I had some nightmare diaper stories. I can't even imagine what that would be like in zero gravity. Oh, all right. Because At things and stuff within me bray 5938. Because every two-body system has because every two-body system has Lagrange points, is it possible to make use of the moon's L2 point? Maybe a radio telescope that is blocking unwanted noise from the Earth. Sorry to add another Lagrangian point question to the pile. Are you kidding? We live on Lagrangian points. That is our fuel. That is how I practice my space knowledge, is to answer every variation of the Lagrange point question. You should not be apologizing. I should be thanking you for more Lagrange point questions. Now, you asked about the moon, Earth, L2 Lagrange point. So once again, every two bodies have 5 Lagrange points, as long as they are vastly different masses. So the sun and the Earth and the moon, the sun and Jupiter, there are 5 Lagrange points. 3 of them are lined up. So you've got the Earth and the moon. You've got 1 Lagrange point on the other side of the Earth from the moon. You've got 1 Lagrange point in between the Earth and the moon. And you've got 1 Lagrange point on the far side of the moon. And then you have 1 Lagrange point that is ahead of the moon's orbit. And you've got 1 Lagrange point that is behind the moon's orbit. The ones that are orbiting with the moon, those are gravitationally stable, while the 3 that are lined up, they are gravitationally unstable. All right. So what can you do with these things, right? I mean, they are helpful little points. So we'll just kind of go through the different Lagrange points and talk about them. So the 1, L4, L5, those were suggested as the locations for the O'Neill cylinder. This is Gerard K. O'Neill had done some work with a bunch of researchers to figure out if we could have giant orbital colonies in space. And they suggested that we house these at the L4 and the L5. And that's why you have the L5 society. And so you would be able to have this giant space station that is gravitationally stable. It's not going to drift out of the point, and it's going to be up at the Lagrange point. It's got a nice view of the Earth, got a nice view of the moon, and it's a good stepping off point to go farther out into the solar system. It's not going to crash into the moon, and yet it's still going to continue to orbit around the Earth. The L2 point, this is the one that's on the far side of the moon. And what this is good for, as you said, one thing you could do is you could put a radio telescope on the far side of the moon, the Lagrange point, and it would be blocked by the electromagnetic radiation of the Earth. And so you would have a pristine view of the cosmos. But the Lagrange points aren't stable, and they're not actually points. They're more like blobs, because when you think about it, you've got the gravity of the Earth, the gravity of the moon, you've got the gravity of the sun, you've got the gravity of the planets. Things are moving around in this region, and so you wouldn't be perfectly stable on the far side, so that the moon is always blocking your view of the Earth. The better way to do that is actually just put your telescope on the moon, on the far side, and then you know that it's going to be blocked. But what L2 works well for is as a relay point. So you can put a spacecraft out at the L2 point, and it can relay communications from the far side of the moon. So if you've got that big radio telescope you've put on the far side of the moon, it can relay all its communications up to the L2 point and then back to Earth. And actually the Chinese did something with this. They had their Chichao mission. As part of their Chang'e mission, they had this relay spacecraft that was on the far side of the moon, and it was able to transmit information from the Chang'e 4, which was at the moon's south pole and wasn't visible from the Earth. And so it was transmitting up to this point and then coming back to Earth, which was pretty cool. L1, which is in between the Earth and the moon, it's a great halfway point between the Earth and the moon. It's not actually physically halfway, but it is gravitationally halfway. And so if you want to have a way station, if you want to have a train station to go to the moon, you fly up to the L1 point, and then you transfer over into another spacecraft, and then you fly down to the moon. And so it's a good use for that. There aren't a lot of uses for L3. This is the one that's on the far side of the Earth. I mean, it's just like it's kind of like a, I don't know, like useless space. Once again, there's not a lot of great uses for the L3 point. This is the one that's on the other side of the Earth from the moon. But there's one idea that I really like, and that is you could create a giant equilateral triangle. So if you go to the L4 point, the L5 point, and the L3 point, these form a giant triangle that is the size of the orbit of the moon. And you put a radio telescope at each one of these points. You can keep them roughly equivalent to each other to maintain this giant triangle, and you've built a enormous radio interferometer, or a gravitational wave observatory, or a visible light observatory. That would be tough. And so if you think the Event Horizon Telescope is powerful, imagine an interferometer that is going, like, I can't even do the math in my head, 500,000 kilometers across. That would be really cool. So I'm sure in the coming decades, centuries, we will think of all kinds of uses for the Lagrange points between the Earth and the moon. They will end up being very famous, very popular places to put spacecraft. Sid Vicious, is the VOD available after the stream? We make it unlisted, but you can, as long as you like bookmark this episode, then you'll be able to come back to it. And then we release it next week to the patrons when we release the actual show. All right. At Matthew Stevens 9579. Is it possible that a captured planet could lurk in the Oort cloud? Also, could we determine this mathematically? It is possible that a planet could be captured in the Oort cloud. It's probable that this kind of thing happens or has happened in the past. When you've got two giant planetary systems moving past each other, the amount of energy that it takes for something right at the very outer limits of the gravitational well to fall into the gravitational well of another star is probably not a lot. And so, it's likely that there are objects here in the solar system that were captured from other star systems. But we know with almost certainty that there isn't anything out there. And that's because astronomers have looked. There was a telescope about 10 years ago called there was a telescope several years ago called NASA's Wide Field Infrared Survey Explorer, or WISE. And its job was to search the sky in infrared, looking for brown dwarfs and large planets in the outer solar system, as well as other things as well. And it was then retasked after it was finished to look for asteroids here in the solar system. And it was so powerful and so capable that it was able to detect any object that was Jupiter-sized out to about 20,000 astronomical units, which is about 0.3 of a light year. And it didn't see any. And it could also find something the size of, say, Uranus or Neptune out to a distance of about 2,000 astronomical units. And it didn't. Now, the Oort cloud is gigantic. I mentioned that it could see out to 20,000 astronomical units. The Oort cloud is 50,000 astronomical units, which is, more than a light year. Like, it's on its way out to Alpha Centauri. That's how big the Oort cloud is. And so there could absolutely be a planet that is the size of Jupiter, that is 40,000 astronomical units away from the sun, that is orbiting within the Oort cloud, and WISE wasn't able to see it. But if it's any closer than about 20,000 astronomical units, WISE couldn't see it. And so Planet X, this mysterious object that is thought to be, so Planet 9, this mysterious object that's proposed to be out in the Kuiper Belt somewhere that is influencing the orbits of other objects in the Kuiper Belt, it has to be a certain size. Like, it can't be the size of Uranus or Neptune and be within a distance of 2,000 astronomical units. It can't be something that is the size of Saturn or Jupiter and be within 20,000 astronomical units. It has to be something that is either the size of Uranus and Neptune and farther than 2,000 AU, or something that is smaller, like maybe the size of Mars, and it's only a couple of hundred AU. So the kind of parameter space that whatever it is that is causing this gravitational interaction in the Kuiper Belt, it's sort of constrained by what WISE was able to survey. And of course, if something does turn up, then say the James Webb Space Telescope would be the perfect machine to go searching for it. Okay. That's all of the prepared questions that I had. So we'll now switch over to the live questions. What a dark forest question. Tesla Ranger, what is your opinion of the dark forest hypothesis? I've done this question in the past, and so if you do a search on my channel for dark forest, you will find my answer to that question. And so the answer I'm going to give now is roughly the same as the question answer that I gave before, but I've got some new thinking on the matter. The dark forest, this is the theory the dark forest theory. This was put out in one of the books, part of the 3-body trilogy by Liu Cixin, which is about that there are lots of intelligent civilizations in the Milky Way, but they keep quiet because they don't want to be murdered by another star system. And so as long as you don't pop your head up, then no one's going to try to take you out. And that theory, I don't really buy it. And that's because there are many ways for us to see other civilizations out there across the Milky Way. We can detect now the atmospheres of other planets thanks to James Webb. I mean, can you imagine what kind of telescope we'll have in 100 years from now, 1,000 years from now, 10,000 years from now? We will have telescopes capable of examining the atmospheres, looking at the landscapes, the mountains, the forests, the trees, the cities on other planets around us. And so if you really wanted to hide, you'd have to live on a planet that has no life, and you'd have to hide underground, and you have to make every effort to hide your existence to the universe. And it's just like, that just sounds hard, right? So it's not about people transmitting a message out like, oh, we shouldn't communicate. That it's that people will be able to passively see that we're here. In fact, life itself, like even if we go, uh-oh, we should keep quiet, life itself has been broadcasting our existence for hundreds of millions of years. If you measure the composition of the Earth's atmosphere with its mix of oxygen and ozone and carbon dioxide and chlorofluorocarbons and methane and all of these things, an alien civilization will be able to put together that there is advanced life here on Earth. So I don't really buy it. And the update is I've been reading the Revelation Space series by Alistair Reynolds. I read the first book. I really liked it. Now I'm reading the second book. I like it even more. I can just tell that this is just going to be great. And now I understand a lot of pieces have fallen into place. And that is if you enjoyed Mass Effect, the Mass Effect video game, and you like the idea of the Reapers as an explanation of the Fermi paradox, Revelation Space has got you covered. In fact, I am pretty sure that Mass Effect was inspired by Revelation Space. Now that I read it, like, a lot of the ideas are very, very similar, but they're better done in Revelation Space. And that is a horrifying explanation to the Fermi paradox. And so if you kind of, if playing Mass Effect gave you the chills and you're like, oh, that seems like a good reason why we're alone in the universe, Revelation Space will do the same thing. So just another vote for this one. I apologize on the book club thing, because now I'm just really enjoying these books, and I'm going to have to read all 4 of them as quickly as I can. And so I won't get into another series until I finish these books. But if you haven't already, Revelation Space, Alistair Reynolds. I don't want to spoil it, but definitely read these books. Holly Buckley, mate, can you please delve deep into the habitability of lava tubes on Mars? It seems like the only sensible option. Thanks, man. I love your work. Now, I've done a whole video just on lava tubes, both on Mars and the moon. And so you can definitely check those out. And I go into all of the numbers and information. If an idea, if you have an idea for, or if you have a question, chances are I have a whole episode with the answer. But that said, I think it's time for a refresher because I haven't talked about it a while. And there's a few new interesting ideas to tack onto this. So yeah, the moon sucks. Mars sucks. The surface temperature on Mars, for example, yeah, in the daytime, it might get up to 20 degrees on a nice hot sunny day. But at night, it goes down to minus 100 Celsius. Also, there's no air, or like 1% the air pressure of Earth. You've got radiation that is hitting you from space that has no magnetosphere at Mars to protect you. So every part of being outside on Mars is awful. You've got perchlorates in the regolith that is toxic if you breathe it. Like it goes on and on and on why Mars sucks. But there are these natural lava tubes on both Mars and the moon, which were formed by lava flowing downhill on Mars, and then the top of it crusted over and the lava kept flowing, and then the chamber emptied out, and you've got this gigantic sort of sandworm tube inside on Mars that you could go and set up inside. And in some cases, we can see these because the roofs have collapsed. You can see where sand is falling down into the lava tube. And so, that's a place to explore. Once you get inside these lava tubes, now suddenly you're protected from the radiation from space. The temperature is actually very mild. You get this average, even temperature. It doesn't really matter whether it's day or whether it's night, but it's reasonable. Now, you still don't have any air, but in theory, you could have some kind of pressurized habitat, or if you were like really adventurous, you could actually wall off a chunk of it and then pressurize it, and you've got habitat inside. On Mars, the lava tubes are bigger than they can be on Earth, and the ones on the moon are ludicrously big. You could have lava tubes that are a kilometer high. And so just imagine you could have a city inside one of these lava tubes on the moon. And same thing on the moon. On the moon, you're protected from radiation. You're protected from, from the temperature extremes. It's the ideal place. And in theory, you could find places on Mars where maybe there's going to be still some sort of briny liquid water that you could examine. So they're great places to explore as well as great places to live. The sort of, because of this, there's a lot of interesting research that's going on to try and figure out what are the techniques that you could actually use to be able to go into these lava tubes, because they're not easy to get at, right? You've got this tiny hole at the top of this landscape, and then maybe the solid surface is going to be hundreds of meters down. You need some way to either fly down or rappel down. And then once you're down inside that, you're blocked from the light of the sun. So you can't have a solar powered object. It's going to be really tricky. And there are a couple of missions that are being considered right now that would say fly really close to a lava tube and examine the surroundings. Other ideas for actually rappelling down. And in fact, there's a group with the European Space Agency, ESA Caves, that just does expedition after expedition to lava tubes and other caves here on Earth, testing out the different kinds of technologies that it would take to be able to explore lava tubes on other worlds. So they're like the best places to go on the moon or Mars, and they help you deal with a lot of the problems exploring those worlds, but they do come along with challenges of their own. But I think we will see missions to both of these kinds of places announced eventually. I don't know who Ben Davidson is. Hold on. I don't know who he is. Chris Mellon, why is SpaceX building a new tower in Florida before trying it out in Texas? I guess because they feel like they've got it sorted. Louis B. Could we use a radar type system to identify asteroids instead of the current visual identification that we're using presently? Absolutely. In fact, radar has been used to map the surfaces of asteroids quite effectively. And the greatest tool that's ever been built to do this was the Arecibo Observatory. Anytime that an asteroid made a close flyby of Earth, say within a few times the distance from the Earth to the moon, Arecibo was called on to image the surface of the asteroid. And the resolution, the radar, when you think about radar, right? This giant dish had this powerful radar instrument. It would beam a radar pulse out from the dish to hit the asteroid, and then some of the radar would bounce back off of the asteroid, and then they would be able to analyze it and be able to map out the shape of the asteroid. And there was a paper that came out just a few months ago. We actually did a story on Universe Today about this, where they released this data trove of all of the asteroids that Arecibo helped analyze. It was like well over 100 different asteroids that were imaged. And in some cases, on some of the closest ones, like the surface features are pretty amazing how well it was able to do. And then, of course, Arecibo collapsed. And this wonderful tool, with this unique capability to examine asteroids and other objects using radar, was gone. But just in the last couple of weeks, they brought online a new radar instrument on the Green Bank Observatory. And this is one of the largest steerable observatories in the world. And now it has its own version. Now, it's not as powerful as the one in Arecibo, but because it's very steerable, you can point it at many different targets, and it's going to have its place. And in fact, we saw this really cool radar image that came from the Green Bank Observatory imaging the moon in radar, and it looks like a photograph of the moon, but it's actually mapping the surface features in radar. So radar is a very powerful tool, a great way to image. And of course, the best thing to do is to send a spacecraft with a radar instrument on board to orbit an asteroid and then map that asteroid out to incredible resolution. So time we're at 5:41. Bravo 1. Can a black hole split in two? No. Nothing can escape a black hole, including a black hole. Retro computing and gaming. If we send a spacecraft to Alpha Centauri, could we use our sun as a gravitational lens to drastically decrease the amount of radio transmission power needed to communicate with it? Yes. And I'm sorry, but like there was a paper that I saw where people were proposing exactly this. And I feel like we covered it on Universe Today. But yeah, in theory, you could, just like you could use the solar gravitational lens as a way to image an exoplanet with megapixel resolution, you could use the solar gravitational lens as a way to focus the transmissions of some spacecraft that it's on its way to Alpha Centauri, and you could receive the information and then relay it back to Earth. That would be really cool. Just looking at questions. Sorry about that. Chris Mullen, have any animals gestated in space? Mice? Yeah, I think rats have been taken to a certain level, but like there hasn't been any proper experiments. There's actually a plan from Roscosmos about 12 years ago where they wanted to send a tiny little centrifuge into space, and they would have some mice on board that they would test artificial gravity with mice, and that never got worked out. Yet another, what is the most fun, hardest part of following science news, especially in space type coverage? You're going to have to tell me. Um, like, I don't follow other people's coverage very much. Like, I follow the journals and I follow the press releases coming from NASA and things like that, and then I interview people. So I don't really spend a lot of time reading other people's coverage. So I have no idea what is good and what's bad about it. I mean, I definitely am browsing through news, Google News, and I'll see like an asteroid is on a collision course with the Earth Moon system, or it's going to come within the orbit of the moon, and this like happens all the time, and it's just clickbait. So, but and I randomly, like when I'm searching for various things, I will randomly come across like really bad videos on YouTube where people are like, I don't know, I have no idea what's going on here. Like, they're like talking about Elon Musk's warp drive or something. Like, I think people are just making stuff up and making videos that a lot of people see, because it's really hard to tell the difference, I think, for a lot of people between what is proper, accurate science news and what is science fiction or just stuff that's made up. I don't know the answer to this. So you tell me what it's like trying to navigate science news out there, because I'm further up the chain. And so I have trusted sources that I go to, and I just ignore everything else. Robert Allen, could a series of starships with built-in telescopes that could land for equipment updates make up for Starlink blocking telescopes on the ground? Like, could space telescopes make up for telescopes on the ground? Sure. Yeah, absolutely. If Elon Musk wanted to launch a space telescope to replace the functionality of every single telescope on Earth, they could pull that off, I guess. But the cost would be prohibitive, and there are a lot of things that are lost from having ground telescopes. Like, the nice thing with a ground telescope is that you can breathe when you walk up to it and you check it out, that you can pull apart some of the instrumentation, you can replace it, swap in other things, you can do tests. There are a lot of interesting observations that are very well made with ground-based telescopes. Space telescopes are better. Like, there's no telescope that is improved by having to go through the Earth's atmosphere, but it's just that space telescopes are so much more complicated, so much more fragile, so much more distant, that they're so much more expensive, that you can get a lot of your observing done with a ground-based telescope before you have to go to a space-based telescope. And the problem is that Starlink and these other mega constellations are going to be causing this just increasing friction. Friction is the way I like to describe this, that before you had pristine skies, that any place you wanted to point your telescope at, you were able to see with the best possibility that you could with your telescope. And now, every now and then, you're going to have a satellite pass through the object that you're attempting to observe. And then not only that, but you actually have this diffuse sky glow that's coming from all of the satellites that is starting to brighten the sky everywhere on Earth. And so all telescopes are getting measurably worse just by the amount of satellites that are out there. But there are ways to mitigate this, right? The best thing is to provide telemetry data. I just did this great interview with Morbid Jaw talking about how if with carefully planned orbits and with really good telemetry information, satellite operators and astronomers can work together almost perfectly, so that the satellites are going places where they're not going to impact the observatories. The observatories are notified when the satellites are going to be flying overhead, and so they just time their observations. So right now it's just the Wild West. People are launching satellites whenever and wherever they want. As long as they get the permission from their government, they send up their satellites, and astronomers are having to deal with this. And Boy, wouldn't it be lovely if SpaceX and other billionaires supplied scientists with an unlimited amount of observatories for them to carry out their observations, but they won't. Come on. So here we are in this world where the world is getting access to high-speed communication, which is amazing. And I think one of the most important accomplishments for humanity is that we get all human beings connected via the internet to each other, to communicate, to learn, to bank, to do commerce, everything. And so that's amazing. And the downside, the price that we are paying right now is a loss of the sky. And it doesn't have to be that way. There could have been ways to come to some kind of agreement, but it's not going to happen right now. Who knows? Maybe later on we'll get regulation. But we see this again and again, right? It's the tragedy of the commons. That, like, what would it cost to launch a satellite? What are the real costs of launching a satellite? They're not just flying your satellite into space. There are externalities that you need to factor in, like the retrieval cost, right? If you're going to launch your satellite with a giant booster and the booster is going to fall back to Earth, it's going to hit some random place on Earth and spread various toxic gases, you have to clean that up. You can't just leave that on the ground or in the ocean. You have to clean it up. And so if we consider the externalities of like almost everything that we do, right? The decrease of soil, the greenhouse gas emissions, the destruction of the ozone layer, deforestation, all of these are done because we don't price in the externalities. And if we did, then various actions would be cheaper, others would be more expensive, and we would have a system of commerce that would match the true cost of doing things. Sorry. What's going on? Someone telling me to breathe? Sorry. All right. Can't look at the chat. The chat is a trap. Oh Chen Zizao. Why NASA never shows us the craft traveling in the space? I know it's dark, but closing to planets, for example, it will be possible to see things clearly. I'm not sure what you're wanting. So, like, you can go outside right now and with a good app, you can time when the International Space Station is going to fly overhead. And you can walk outside, you can look up, and right on time, this gigantic space station flies overhead. It is the brightest object in the sky after the moon and the sun. It's as bright as the planet Venus. And you can set your watch to it when it flies overhead. And with a good pair of binoculars or a small telescope, you can actually see the shape of the International Space Station just with your own eyes. Like, you're looking through binoculars, you're looking at the station, and you see it. It's possible. But that's not all. You go to a website like Heavens Above, and you can track all the satellites, all of the spacecraft that are out there. You can watch, for example, when a Dragon spaceship is launched to the International Space Station, and you can see the space station fly overhead. And then you can see the other little dot of the spacecraft that's getting closer and closer and closer. And if you're in the right part on Earth, when the docking happens, you can actually see these dock together, or the Soyuz or whatever. When James Webb Space Telescope was flying out to its L2 Lagrange point, various astronomers around the world were able to actually see it. They were able to see this dot. It's just a dot, right? Like a dot that reflects light because it's very far away and it's very small compared to larger things. But once you're out in deep space, it's impossible to see them because they're so tiny compared to like space itself, and the amount of light that's going to reflect off of this spacecraft is minuscule. But there's been some examples where spacecraft have had selfies. So the Chinese mission to Mars on the orbiter spacecraft, they had a little tiny selfie camera that they released as the spacecraft was in orbit. And so we were able to see the entire spacecraft. And then down on the surface of Mars, the Zhurong rover, it placed a selfie camera on the surface of Mars, then it backed away and it took a picture of itself. Of course, during the Apollo landings, as the spacecraft were taking off from the surface of the moon, they had an automated camera that sat on the moon and tilted up and watched as the Apollo lunar ascent module took off. We got some examples of landings on Mars. So for example, when NASA's Perseverance or Curiosity rover were landing on the surface of Mars, the Mars Reconnaissance Orbiter was flying directly overhead, is able to watch these spacecraft as they landed on Mars, was able to see the parachutes, and has been able to see the rovers from space. When the Lunar Reconnaissance Orbiter went to the moon, it was able to see the Apollo landing sites from orbit of the moon. It was able to see the footprints of the astronauts walking around. So nobody shows images of spacecraft in flight because you would need to send the cameraman along with the spacecraft to take your video. And that's really tricky. So you just get the images from the spacecraft of what it's seeing. And if you're lucky, like say with the Artemis mission, there was a lot of cameras on board. The spacecraft was able to see the actual capsule in position while it's going around the moon. But it's very rare. Most of the time, just the spacecraft is equipped with a camera and it takes pictures of the things that it's seeing, because it's kind of ridiculous to send another camera to take images of a spacecraft. Just, I don't know, to prove to people that it's there. I don't know why, but then the Chinese did it. So I guess it's awesome. There you go. Oh, you're going to have fun editing that one, Chad. What are we at? Whoa, 56. Man, time flies when you're having fun. J.M. Mellinson, if you could step into a time-slowing machine, would you want to fast forward to the future? Yeah. Yes, I want to see the future. Badly. I really want to know what happens. I mean, obviously, on the one hand, we have science fiction, Star Trek, Star Wars. I know it's in the past, also in a galaxy far, far away, but still, it's futuristic. Stargate, but other just like science fiction ideas. What will the future hold 100 years from now, 1,000 years from now, 10,000 years from now? Will humanity still be around? Like, assuming we're still around, then the future has got to be interesting. And I would love to see what happens. And I'm sure we're going to do some really interesting things in my lifetime, but it won't hold a candle to the really, really interesting things that are going to happen in future lifetimes. So yeah, I think if I could go forward in time and see what happens in the future, I would like to. And my wife would too. Like, if I know my wife, if there was a button we could both press to see the future, like she's as much of a future nerd as I am. Would my kids? Like, that's all I want to make sure my kids would probably press the button too. So hopefully as a family, we'd be able to move forward into the future. But yeah, I really want to see the future. And that's like that's part of the motivation, I guess. That's why I do what I do. And that's why I sort of, where I sit on the space news, science, content sphere is I like to live right on the bleeding edge. What are the new ideas? What are the stuff that's going to be in the future? What solutions are being worked out to problems? What new discoveries have just been made? What spacecraft have been announced? I'm always trying to live 5, 10, 15 years into the future. And it's, for the amount of time that I've been doing this, right, closing in on 25 years now, I've been able to go through the entire cycle. Like, I remember when New Horizons launched, and I was thinking, boy, it'd be so cool that in 10 years from now, we will see pictures of Pluto. And yet I was able to go through the entire process, reporting on all the trials and tribulations of the spacecraft. And finally it reached Pluto and we saw those pictures. And then it reached another object. So, I have no regrets, but I would love to see the future. Okay. That is the questions are going to go into the question show, but don't go anywhere. This is just the end of this part, but we're going to stick around and do some overtime. So stay tuned. Don't go anywhere. Do not leave. So I got to record some outro bits, and then we'll get in there. If you like my answers to your questions as well as the other things we do at the Universe Today, consider joining our Patreon club. This allows us to keep minimum ads for everybody. Like, as you can see, there are no ads during this video. As a patron, you also get an ad-free experience. Oh, shoot this again. Like, as you can see, there are no ads during the middle of this video. As a patron, you also get an ad-free experience on universetoday.com for life. Even if you unsubscribe, you get ad-free videos, early access to interviews, as well as other perks that are exclusive to our Patreon community. Thanks to everyone who's already subscribed, and welcome to our newest... Thanks to everyone who has already subscribed, and welcome to our recent newcomers. John Fickle, Niels R., Scott Nixon, Richie Stewart, Jake, Auden Malman, Justin Steiger, Roy Corbin, Ray Latoul, and Paul March. Join the club at patreon.com/universetoday. A little bit more outro, and then... All right, those are all the questions that we had this week. Thank you, everyone, for asking them. Don't forget to vote for the question that you thought was the best. And remember, we do the show every Monday at 5 p.m. Pacific time. So if you want to join the show live, you can do that right here on my channel. There will be a link to the next show that you can subscribe to, notify yourself. If you don't show up live, that's probably YouTube's fault. I know people get notifications late. All right. And then if you want to stay on top of all the important space news, join my weekly email newsletter. I send it out every Friday to more than 60,000 people. I write every word. There are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Tim Whalen, Dave Verabioff, Josh Schultz, and Andrew Gross, who support us at the Master of the Universe level. All your support means the universe to us. And then I've got to do... That outro might not be great, Chad, so... Mark Geyser. How's that? All right. I'm gonna record the outro because I sort of rambled there. All right, those are all the questions we had this week. Thank you, everyone who joined both live, but also asked questions in the YouTube comments. Remember, we do this show live every Monday at 5 p.m. Pacific time. So if you want to have the longer episode experience, come join us live. And don't forget to vote for the question that you thought was the best. We'll see you next week. That was better. Okay, and then I got to do one last piece, and then... Oh, so many questions. Wow. People have been busy. Is that not working? Page 2 of 2? So I'm having trouble navigating to the next page, Chad, to be able to see the questions. So there's 100 questions on the page. And then I try to go to page 2 and it doesn't work. So I can't see the questions that we already got, but I will just try to remember them. Can there be black holes that don't spin? Is there any use for the moon Earth Lagrange points? And would I like to live in the future? All this and more in this week's question show. All right. Let me stop the recordings. All right. Take a drink of water. And then I will hit the questions fast. All right, let's try this. I'm going to start at the top now. Earliest questions first. And I will go fast. Are there antineutrons? In theory, have antineutrons ever been made? Yes. It was discovered in 1956. Bravo 1, how will understanding dark matter revolutionize our understanding of physics in the universe? It'll just help us understand why are galaxies if we can't perceive 85% of the universe, then we're not really knowing the universe. So that's how we'll revolutionize it, is that we will understand the universe. Arjone, is there a way to differentiate a black hole from a really dark neutron star? Could you tell by sight, or could LIGO hear the difference? They can definitely hear the difference. I mean, if you had colliding neutron stars, you would get a certain frequency of the gravitational waves as the two neutron stars were about to collide. There's a really cool audio sequence that NASA released, or LIGO released, for the sound of two neutron stars that are orbiting around each other, and then they collide, and you get this sort of whine that gets higher and higher and higher. But yeah, it's mass, and the mass you get from the mass you get the frequency of their orbits around each other, and that's how you would know. Margaret Leach, I'm new here. What do you think about those lights on the moon? What lights? There are lights on the moon? Not that I know of. Mike, could we use gravitational flexing to generate power like Io does? Sure, geothermal power is essentially gravitational. I mean, it's the same as gravitational flexing. And so if you could have geothermal plants on Io that would be producing power. Stephen Collins, what are the priorities of figuring out a place to have an outpost on Mars? Is there a place that really brings them together? So I've got an interview coming with the person who is responsible for choosing landing sites for a human mission to Mars. And so I'm going to ask him those exact questions, and that's going to be coming in the next couple of weeks. I haven't set the interview up yet, but essentially it's the chair of the Human Mission to Mars landing site group. So stay tuned for that. Memarjono, HLS seems to scupper Artemis timeline. So HLS, the Human Landing System, that's the Starship designed to bring astronauts to the surface of the moon. Is it scuppering the Artemis timeline? So far, no. But if there are any more delays to Starship and they don't actually test out an HLS on the moon in time for Artemis 3, which is probably 2026 at this point, 2027, then it will cause delays. And we're going to find out. I hope not. I hope everything goes according to plan. Hammerfan, would it be possible, in your opinion, for a planet orbiting a star system with a pulsar in it to have life, to have it before the star going nova and survive? Probably not. The environment around a pulsar is terrible. There's really intense radiation. You'd have to orbit pretty close to the neutron star to be in the habitable zone of the amount of radiation that's coming off your neutron star. It would suck. But under the surface of the planet, it could be habitable. And so if the planet was once habitable and then the star went supernova and then the planet ended up in orbit around the neutron star below the surface, you would expect that life would continue. Earth life, even if the surface of the Earth was uninhabitable, there would still be tons and tons of life inside Earth. Just something big. There'd be no platypuses, there would just be cyanobacteria. Chris Mullen, does the black hole spin tell us anything about the size of what's inside? No, unfortunately. It's really hard to know what's inside a black hole. Sespunet1, how fast does gravity travel at the speed of light? So if the sun blinked out, yes, we would be orbiting where the sun was for about 8 minutes. Zach Diecast Manser, does time overlap on itself as it trails farther and farther as it spins and then sees? I don't understand the question. I'm sorry. Like around a black hole? Does time? No. Because you never go faster than the speed of light. You get backwards time travel, you go faster than the speed of light, but you can't go faster than the speed of light. Andrew Malaire, what if we find that nuclear fusion that produces more energy than energy is spent to build it and run it is impossible? Well, it's not. We know that it's not impossible. The sun is doing it right now, so it's an engineering challenge. It's not impossible. Tesla Ranger, how does one calibrate a gravitational lens? I think one just observes with gravitational lenses. I'm not sure you calibrate it. Tom Garcia, could finally achieving nuclear fusion be what killed the dinosaurs? Perhaps there's always being 10 years. Yeah, I think that's exactly what it was. They cracked nuclear fusion. Jack Woods, is it highly unlikely that the crisis in cosmology is because of dust causing incorrect Cepheid data? It's highly unlikely that it's dust. I mean, there's been a ton of different measurements that help reinforce the Cepheid data that are independent, but like it can always be dust. Like dust is always the problem. So never rule out dust. Never bet against dust. Erie, if two black holes approach each other at faster than the speed of light, each moving over half the speed of light, hit each other, would they merge, would go through each other, or explosions? Nothing. They would merge. And now you'd have a black hole with the mass of both black holes. I don't understand the question. Nicholas Lindquist, what is the differentiating theory arguing the sun is comprised of gaseous plasma rather than all forms, including solid and or liquid plasma? I don't really know what the differentiating theory is you're talking about. Ghost Dog 4, is the edge of the universe theoretical or an educated guess or question mark? There's probably no edge to the universe. The universe is probably infinite in all directions. So there is no edge, but even if the universe isn't infinite in all directions, but it's actually finite, then it probably wraps. So it's kind of like saying, where is the edge of the Earth? If you move in one direction on Earth, when do you reach the edge? And you don't. You just return to your starting point in any direction that you want to go. It's kind of like that, but in the universe. Michael Hurt, if there's something beyond the observable universe, how can we see the CMB? Shouldn't that be beyond what we can see? Isn't that earlier? We see the point, the farthest that we can see. And so every minute that goes by, we see a new piece of the CMB. The light was released 1 minute later, and then the light was released 1 minute later. And so we're always seeing the beginning of the universe in all directions when we look. And so we can't see how the universe looks today. We can only see it backwards in time. And the limit is the beginning of the universe. Mark Geiser, when we terraform Mars, does it even have enough gravity to eventually sustain an Earth-like atmosphere pressure-wise for us humans to walk around without helmets? Yeah, you could eventually have a way that it's going to be tricky for you to be able to walk around without a helmet. I think you will, even on a well-terraformed Mars, you're probably still going to need some kind of pressure suit. There just isn't enough gas to produce the thickness of pressure. So you can get a temperature, you can get water, but you'll never really get good air pressure or protection from radiation. Simon says 55. Would you get stronger babies in higher gravity? Probably not. You would just get, we evolved in the gravity that we live in. And so if the gravity was too high or too low, you get problems. Arjun, if Elon Musk or China seems to be making great progress in getting to Mars, will this spur more development on biospheres? I see a lot of work on getting to Mars, but not a ton living there. Yeah, Biosphere 2 was one of the greatest experiments that humanity's ever done. If we want to go to space, we should get that experiment going again, and many like it, and run them to fruition to understand all the challenges of attempting to live in space. Like if you're serious, you want to live on Mars, then you need to be building super biospheres. Zach, what will happen to the universe? Big crunch or heat death? Heat death is the consensus of scientists today. The INRAB, if the Earth was 10% bigger or 10% smaller, how would that affect our ability to launch rockets into space? If Earth was 10% bigger and had the same mass, then it would be a little bit easier to launch rockets into space. Essentially, the surface gravity would be lower. If the Earth was 10% smaller and the same mass, then it would be a little harder to launch rockets into space because it would be the essentially the density is lower. Like when you look at like a super Earth, something that is twice the mass of the Earth, but it's only say 1.5 times the size of the Earth, it's not twice the surface gravity. It's less. So a little bigger, same gravity, easier to launch rockets. A little smaller, same gravity or same mass, harder. Satum, why doesn't the sun's gravity affect the Lagrange points for the Earth and the Moon? It does. It's just it's negligible for keeping things away from the stability. You have to incorporate them into your, when you're maintaining thrust to manage your position at the L1, L2, or L3 points, you have to take into account the gravitational interactions. You're constantly having to use propellant. It's just the least amount of propellant to remain hovering in this location. The other thing to use Lagrange points I didn't think of is that you can build a lunar elevator from the L1 point, which is pretty cool. Mark Hearn, could we build city-sized structures at L1 or L2? We could, but they're unstable, and so you would lose your city as it fell out of, like, can you imagine the amount of propellant to maintain position of a city? And if you didn't, then it would crash. Pastel Assassin, if vacuum decay were to occur in a galaxy moving away from us faster than light, what would the vacuum decay do once it reaches the areas of the universe that can no longer catch up to? Well, it can. So if it can't reach it, if the places are going faster than the speed of light, then it can't reach them, and so nothing will happen to them. The vacuum decay will always be going at the speed of light, reaching whatever regions that it can, and they will be impacted and other ones won't. And remember, like 94% of the universe, of the observable universe, is inaccessible to us, even if we could move as fast as the speed of light. So if we let off a vacuum energy bomb here, it would only take out 6% of the observable universe, would join us in this vacuum state. The other 96% will have already escaped. Zach, if Elon Musk starts calling on Mars, could he proclaim himself king of Mars? Sure. He could do whatever he wants. Will people agree to be ruled by Elon Musk as king? I mean, I guess he flew them to Mars. Just look at human history to see how that all works out. Tom Watson, could the universe be empty because everyone is all left for a better alternative universe? I guess, but it seems like a waste of space. I mean, sure, there could be nobody at your party because everybody has gone to a better party. Yes. HQ Cart, why is the lowest temperature of space 0 Kelvin and not minus infinity? Does this mean that there's something that is heating up the universe? Yeah, the thing that's heating up the universe is the leftover temperature of the Big Bang. So, back at the beginning, it was millions of degrees. Then when the cosmic microwave background radiation was released, it was like 5,000 Kelvin or 3,000 Kelvin. And now the temperature of the universe is 2.7 Kelvin, just left over from the heat of the Big Bang. And that temperature will always be there. It will never be 0. Sid Vicious would love an explanation for the time dilation in the Miller's planet scene from Interstellar. Why is time different on that planet than Earth? Having trouble understanding. I actually have a new interview that just came out or will be coming out in the next couple of days about philosophy and relativity, and we talk a bit about that. But the gist is that when you're in a gravity well, you experience time dilation compared to somebody who is not in a gravity well. So you down on the surface of the Earth are experiencing different amounts of time than a person who is orbiting the Earth because you are closer to the Earth's gravity. And it's just how the universe works, man. And Interstellar sort of did the math. Andy Oates, could there be a Lagrange point between our solar system and Alpha Centauri? They have to be different masses. So our solar system and Alpha Centauri are roughly the same, so you won't get Lagrange points. David Litton, could we terraform Titan? No. It's too far away, and so it's just too cold. I mean, you have to provide your definition of terraform. If terraform is huddle in a freezing research station, then sure. But if you want like a place that is, the only way to terraform Titan is to move it close to the sun. Like if you brought Titan in to the distance of the Earth, then it would become a water world and would probably be habitable. Chuck Lewis, you'd mentioned that 95% of the galaxies we see are moving away from us faster than the speed of light. What are the relativistic effects on that observation? They redshift. So the galaxies are redshifting. So the light coming from them just redshifts. And so they'll never disappear. They'll just fade away. The light will just grow and grow and grow, redshift to radio waves, and eventually they'll fade from our view, but they'll always be there in our sky. Boomsy, what IQ do you need to be an aerospace engineer? They did a study with surgeons and the absolute lowest was 112. Just wondering. IQ is such a bullshit terminology. So, like, don't worry about it. Like, here's the thing. Science is math. And nobody likes doing the math except for the mathematicians. But for everybody else, like, you're going to have to do math, and it's going to be work, and you're going to have to practice. And you're going to learn the calculations, and you're going to do the math, and it's going to be hard, and it's going to suck. But eventually, over time, the calculations will work in your brain, and you will get practice, and it'll never come naturally to you. You will always have to work for it. But after a while, it'll just become part of the job. And then you get to do the cool part, which is you get to design rockets and aircraft and run calculations on aircraft wings. You have a lot of computers helping you. So I think like people think that they're good at math or they're bad at math. And I don't think that's true. I mean, I think there's some people who are just like naturally talented at math and they really enjoy math. But for the vast majority of people who have to use math, you just have to practice it. Like you have to take your algebra problems when you're in high school and you have to do them 100 times over. So you've seen every single variation of it. It's a practice thing. You never get to a place where you just look at a problem and go, oh, I know the answer to this. Like everything is practice. Everything is hard. Everything is work. And if you want the outcome, which is to be an aerospace engineer, and you should because that's awesome, then you're just going to need to do the math. And so don't worry about whether or not you're smart enough. Just do the work. Do the work. Like when I went to university when I graduated from high school, I went to engineering and I failed out of engineering because I wasn't ready to do the work. I was too interested in making a video game company, hanging out with my friends. Like I just wasn't into it. And then I went off into the real world and I worked at some software companies for a while. And then I came back around and went back to university like maybe 12 years ago or so to finish off getting my degree in computer science. And I destroyed it, right? Because I knew how to do work. I knew how to be efficient. I knew how to focus my brain. I knew how to be disciplined. I knew I had learned how to learn. And you need to learn how to learn. And like, I've taught my kids this. So the lesson is relatively straightforward, which is that if you want to learn how to do something, you figure out what it is that you don't know how to do of that thing. And then you take that part and you just grind it until you know how to do it. And then you grab a different part. And like, think about when you're playing a video game, right? You're playing a video game and you're trying to get past some certain boss and you practice on that boss over and over and over and over again until you finally can get past that boss. It's just like that, except you get a paycheck at the end as opposed to not. So imagine real life is like a video game, except there are real tangible benefits for progressing. I believe in you. You're smart enough. Get at it. Gray, do you have a favorite unanswered question? No, I mean, there's been a couple of times when people ask me questions that I didn't know the answer, and I thought they were really fascinating, and so I posted them to Twitter to see if anybody else knew the answer, and I forget what those were. Jack Woods, can you comment on the galactic habitable zone? I made a video on that, but the gist is probably you need a certain part of the Milky Way for life to form. Too close to the core, there's too much radiation. Too far out, there's too few metals. So you want to go just right, but even that people argue about. Eerie, if mankind ended tomorrow, how many years would it take to have all of our satellites fly away or just deorbit or fall? So all of the low Earth orbiting stuff would be gone within 5 years. Stuff that's in the medium orbit, say 500 kilometers to 1,000 kilometers, would happen over decades and hundreds of years. And the stuff that is up in geostationary orbit would be effectively be there forever, 1,000,000 years. Okay, I'm going to wrap up here. Jonathan Allen, are your kids interested in space or just Minecraft? I think they're tangentially interested in space. You know, they don't plan to make it as their career. I think one kid is going towards law, and the other kid, I have no idea. All right. Well, thank you, everyone, for joining me today. And thanks to Nancy Graziano for putting the questions into the database for me to answer. I really appreciate that. Thank you, everyone watching. Thanks for everyone who asked a question. I'm sorry I couldn't get to more of your questions. They were building up faster than I could answer them. I don't know what to do. It's like a bucket that I'm emptying out, and it's filling up faster than I can. So, what's coming up this week? So some of the interviews with the NIAC Award recipients are getting scheduled. So we're probably going to have a big whack of them to release over the next couple of weeks. We're trying to think of something special to do with these. So stay tuned on that. We're going to be doing Astronomy Cast tomorrow because today was a holiday in the US. There's no more weekly space hangout. Wah, wah. Sorry, everybody. I think that's it. All right. Thanks, everyone. And we'll see you next week. Where's the button? Found it.